Uh, first off is the 7-step process in developing a method, and this is Haley Henderson. And the first step is clearly define the problem. And for us, we needed to calculate the crop yield. To do this, we needed the acres and the bushels for the acres. Next slide. Step 2 is develop a test matrix. And you can see here our inputs are acres and bushels per acre, and our output would be the crop yield. And we came up with 5 unit tests with different variables. Next slide. And can you find the one that's 3? Okay. Steps 3 and 3 through 5 are all shown here. Step 3 is to create an outline of the solution, and we did this in the comments above the actual code. And step 4 is testing the algorithm. We took our unit tests and put them into our algorithm to make sure our logic worked. And then step 5 is writing the actual Java code. And you can see how our function signature is there, as well as the code in the function to calculate the crop yield. Next slide. And step 6 is to run the unit test cases to make sure our code was working. And so I have here 2 of the 5 just to show you that we took our test matrix variables and put them in place of there for the testing. And we had our acres, which is 10, and our bushels per acre is 15, and our expected result, we figured the crop, which is the crop yield, would be 150. And we were able to test those, and they came through as a pass. Next slide. And then the last step is 7, and it is to deploy the code. And this is where we commit our work and push it to our repository. And this slide just shows kind of the menu of how to get there. Going to your Git remote, and you can either commit there or push and pull. Next slide. So this is my individual assignment. This is my selection code, which was used in developing the game menu view. Once this view is open, the game menu is displayed, and the player enters an option number from this system outprint. My selection statement is within my repetition statement. Next slide. The computer starts its validation and begins an if-else-if ladder statement to determine where the player wants to go. So it's just looking at what they did enter, the option that they entered. Next slide. And then here is my my other individual assignment where I unit tested the control layer. Here I have the function to calculate the population. I had developed a test matrix in the 7 steps. Next slide. And the inputs from my matrix was entered into my unit tests. I created 5 unit tests, and they all came out with a pass, and you can see where I put in the current population, the move in, and my expected population would be the expected result for the population. And that's all. That just shows my other tests.
Okay, I am Brennan Nielsen, and I'm going to be starting by talking about passing by reference and by value and the differences there. So in Java, when you're passing by reference, that essentially means that the argument that you're passing can be modified within that function you're passing it to. And in contrast, when you pass an argument by value, that argument cannot be modified within the function that you pass it to. So we see passes by reference a lot with primitive data types. And then we see passes by value a lot with objects. And so the objects that we use in our game here, like the player, its properties, those are always passed by value. So like, for example, in the second example down there, if you set, you're passing the string player name into that function. If you then go into that function and set player name equal to a different string that was passed into, that would not reflect in the end result. And here are some examples of different selection statements within my code. And common selection statements are obviously if and if else, and then there's also switch statements that you can use. The if and if else statements are very effective. There's no visible difference between an if and if else and a switch in this program. I did a little bit of research and saw that a switch could potentially be faster in some cases if no logic was needed, if it was just looking for a specific integer or string. But the if and if else are very valuable to our game here. And as far as unit testing goes, I wrote some unit tests for the test calc crop yield function. And I wrote 5 of those. 4 are displayed here. But the inputs, acres and bushels per acre, come from our test matrix. And so the computer picks that up and it runs through all those test cases. And then it prints out your result. And then a successful test will look something like this. You get your output printed, and then you get the build successful message down below it. So that's how you know that you've built and run a successful unit test. And that's it.
All right, I'm Darren Kearns, and I'm going to go over a couple things here. This is our individual project that we need to talk about, and then I will also be covering the scope variable and lifespan of a variable as well. So to begin with, in the individual project this week, I covered the byland portion, and we can see here at the beginning of it, we created the byland, and then we're calling in the crops object, and then we started creating some variables or pulling different variables from other portions of our code. And then we had, in this particular one, I had an if else statement. So if when we queried the user for a number, if it was less than 0, it would query them back and say, please enter a positive number. And then we have an else. So if they actually did put in a positive value, then it will go through and it will run the different calculations. And then towards the bottom there, it will give a printout of the successful byland portion of what we were trying to do. Next slide. So here I ran the code, and you can see that I had 28 bushels available to sell, or to buy land, I guess, if you will. And I wanted to buy 10 acres of land. And so I did that, and then we ran the code, and now I have 110 acres of land. I lost 3 bushels of wheat. Now we have 2,797 bushels in our stores. Next statement, or next slide, sorry. So now we're going to talk about the scope of a variable. Next slide. So in lesson 6, we learned that the scope of a variable is confined to the block that the variable is defined within. So if we take a look at the crops view class for our project, the current land variable is defined within the byland block. its scope is the function block, so it can only be used within that function. So next slide. So what that means for us is we can if we go to our if-else statement, we have the acres calculation block. And the acres calculation block is a block that defines the action when the if statement evaluates to true, and it can only be used in this block. Next slide. Okay, and then now we're going to talk about the lifespan of a variable. Next slide. So the lifespan of a variable starts when it is first defined and allocated in memory. So as you can see here where we see the birth, this is when the variable is first called and then it gets allocated into memory. The current land variable is defined in the byland block, and memory is allocated to it when the function is called. Next slide, please. And then if we look down at this one, the wheat yield variable is defined in the else statement block. And then memory is allocated for it when the statement defining it is executed within the block as well. Next slide. So in this we can see that a variable's life ends when the execution reaches the end of the block that it is in and what it is allocated for. Next. Or that's the end of what I have.